Assalamualaikum and good evening. My name is Imran Arazi bin Heru Rizal from the School of Mechanical Engineering, Section 6 of SEMM 2713 Manufacturing Process. And today I'm going to be presenting on my polymer assignment, which is polymers in 3D printing. Okay, for a brief history of 3D printing, 3D printing, or another name that you can call it, additive manufacturing (AM), is where precise geometric shapes are added and combined into printed layers. Starting from 2010, there was a standard for 3D printing, which was the ASTM F2792. But in 2015, the standard terminology was decided and replaced the old one, which is now ISO ASTM 52900, which states that 3D printing is the process of joining materials to make 3D parts, to make parts from 3D model data, which usually is layer by layer. The main materials of 3D printing are metal, ceramics, and polymers. For the processes of 3D printing, there are 7 main categories from the previous stated ISO ASTM 52900, which are binder jetting, directed energy deposition, material extrusion, material jetting, powder bed fusion, sheet lamination, and wet photopolymerization. Some of these processes uses polymer as a main input material. For polymers, the selection is used based on the environment and the properties required for the desired product. These polymers can come in various forms such as resins, photopolymers, filaments, plastic wires, pellets, and powders. Some of the most used polymers are thermosets, thermoplastics, elastomers, hydrogels, polymer blends, and polymer-based composites. For thermoplastics, thermoplastics are polymers that become liquid under certain pressure and temperature and can be processed repeatedly, extruded or injected. They have good mechanical and chemical properties but can be improved by adding additives. Some of the most used thermoplastics are polylactic acid (PLA), acrylonitrile butadiene styrene (ABS), and polyethylene terephthalate glycol or PEG. For 3D printings, one of the polymers used are liquid polymers. Liquid polymers are polymers that are solidified using treatment, either thermal or UV light. They can be divided into two, which are photopolymers and binders. Below you can see the pictures of photopolymer resin and liquid binder. For photopolymer resins, they are mainly used in wet photopolymerization and MGT. These resins are usually made of monomers, oligomonomers, photoinitiators, which and other additives. Low viscosity resins are used in VPP, while MJT relies on resins with different viscosities than low viscosity for resins used in VPP. The MJT needs resins with viscosity of more than 50 centipoise and at higher temperatures with between 15 to 20 centipoise. Commercially, for photopolymer resins, there are mixtures of acrylics and epoxides where acrylics change the reaction rate of the photoresin and epoxides are responsible for the strength and toughness of the resin, of the polymer. For photopolymer resins, they can be classified based on their application and how they are cured. For application, they can be called standard, flexible, industrial, castable, modeling, and dental resins. Based on the curing method, they the resins are cured using UV laser, UV DLP, and daylight resins. Another liquid polymer are binders. Binders are liquid in nature, which are polymers that are solvent or in aqueous solutions used in BJT, binding jetting. There are two classes: organic ones and inorganic ones. Organic ones usually are more widely used, but inorganic ones usually leave less impurities in the final product. Organic binders include butyryl resins, polyvinyls, polysiloxanes, polyacrylic acids (PAAs), acrylosols, which decompose with heat. Inorganic binders are silica colloids, which react to acid to lower the pH and prevent excessive binder migration. These binders must have a bare minimum viscosity range of between 5 to 20 PS and a surface tension range between 35 to 40 millijoules per Newton. Another type of polymer used in 3D printing are polymer powders. These polymer powders are used in powder bed fusion, selective laser sintering, multi-jet fusion, and also in PJT. These thermoplastic powders are usually semi-crystalline, but amorphous and bisurfactant one can also be used. Powder flowability is a major factor in creating a homogeneous layer on the powder bed, which is affected by the particle size of the powder. Uh, Powder bed fusion usually has an average particle size of 20 to 45 micrometer, while in BJT they usually have a particle size of 20 to 35 micrometer. The particle size also affects the roughness and the product finish. As you can see, 95% of the powders are semi-crystalline polymides, which are PA11 and PA12, with PA12 providing the best performance and makes up 90% of the market share for polymer powders. Other powders can also be seen in the pyramid, which can be classified either amorphous or semi-crystalline. They also are segmented in three different layers: high performance, engineering, and commodity. As you can see, semi-crystalline is you can say PA6, PP, PE, PET, PAEK, and PBT. There are also elastomers with like TPU and amorphous one like polycarbonate and polystyrene. Another type of polymer shape or say, is filaments. Filaments are usually strands of thermoplastic polymers with a diameter of 1.75, 2.85, or 3 mm, which is wound in the spool. Depending on the mechanical and physical properties of the filament, different properties can come out from the 3D print. These filaments usually use MEX, material extrusion, processes such as fuse deposition modeling and fuse filament fabrication. As you can see, polymers considered easiest to print are PLA and PETG. PA and PC are a little harder to work with, and ABS requires stable temperature and a chamber to get high quality prints. Other powders can also be classified into a pyramid, like the powder such as which have the same classifications of amorphous, semi-crystalline, and layered by high performance, engineering, and commodity. Another type of polymer shape is are pellets. Resin pellets are extruded into filaments used in FDM and FFF, like as stated before. But there are new technology to use the pellets directly, such as fused granulate fabrication and fused pellet fabrication (FGF and FPF respectively. Pellets are considered 5 to 10 times more cheaper than filaments, which could eliminate such problems from if you use filament as a main polymer, such as slippage and buckling. The main type of polymers are the same as filament type, which are PLA, ABS, HIPS, PET, and PETG. Another type of polymer used in 3D printing are biopolymers. Biopolymers are considered important and are used in biomedical applications. The biomedical market represents 11% of the total 3D printing market and provides a significant driving impact on the development of the market and the technology. There's a need for printed scaffolds and prostheses for fabricating hard and soft tissues. Uh, for example, for 3D bone scaffolds, materials containing hydroxyapatite and polymers such as PLA, PLCA, and PLGA, where fused deposition material is used to print. As for hip and knee implants, SLS sintering technology is used with materials such as PCL and metacrystalline copolymers. In conclusion, polymers represent a key material for input material of 3D printing, where its properties influence which technology and processes is used to produce a print. Understanding the intricacies of what properties and which polymers are good for which process allows us to further the implementation of 3D printing and widens the range in which 3D printing or additive manufacturing (AM) can further help humanity. Thank you.